This year, Japan plans to take a step that many considered science fiction, to launch the world's first robo-taxis based on autonomous quadruped robots called Corio. This is not just an experimental service, but a real project that has reached the stage of commercial testing in Tokyo and other major cities, taking into account millions of passengers and complex urban infrastructure. The core of Corio is a combined autonomous navigation system that includes LiDAR, radar, high-resolution cameras, and an AI module for predicting the trajectories of surrounding objects. Unlike traditional wheeled transport robots, Corio uses a four-legged platform that allows it to confidently overcome obstacles, sidewalks, and even stairs, for example in pedestrian zones, or when picking up a passenger from a dense crowd. Each Corio robo-taxi is equipped with a next-generation computing unit capable of processing terabytes of sensor data in real time. This means the machine not only follows a preloaded route, but actively analyzes the behavior of people, other vehicles, traffic signals, and emergency situations, all with high-speed decision-making. Motion control is handled through a combination of local AI and centralized cloud models. The local AI is responsible for immediate actions such as trajectory adjustments, stopping, and obstacle avoidance, while the cloud AI collects data from thousands of robots, identifies patterns, optimizes routes, and forecasts traffic. This architecture makes Corio not just an autonomous taxi, but an intelligent participant in the city's transportation network. One of the key advantages of this robo-taxi is flexible adaptation to weather conditions and traffic density. Corio robots have already successfully completed tests in rain, foggy conditions, and evening hours when visibility is reduced. Moreover, the system can adapt to local urban specifics, such as narrow streets, dense intersections, and even pedestrian zones, where conventional autonomous vehicles often struggle. However, what makes the project truly breakthrough is not only the technology. Japan has long faced a demographic crisis and an aging population, meaning that traditional taxi services and public transport often struggle to meet the needs of all citizens. Corio offers a solution that simultaneously reduces the burden on human drivers, increases transport accessibility, and minimizes technical limitations. The transition to mass deployment of robo-taxis is not only an innovative stage in mobility, but also a real challenge for urban infrastructure, requiring dedicated corridors, highly reliable communication systems, and digital twins of the city synchronized with the movement of every robot. In essence, the launch of Corio in Japan is a test that will show whether an autonomous robot taxi can become part of everyday life at scale, rather than only in pilot zones. And if successful, it could mark the beginning of a new era in urban mobility, where transport does not simply move on its own, but interacts with people, the city, and AI infrastructure as a unified system. Moving from ground-based to flying taxis of the future, FlyNow Aviation has introduced its electric e-copter, a compact EV toll aircraft designed for urban transportation and air taxi services. The e-copter is built with a coaxial configuration featuring two rotors mounted one above the other and rotating in opposite directions. This design simplifies the mechanics compared to traditional helicopters, reduces the number of components, and lowers operating costs. The aircraft is being developed in single-seat, two-seat, and cargo versions. The maximum payload reaches approximately 200 kilograms. The range is about 50 kilometers on a single charge, and the top speed is up to 120 to 130 kilometers per hour. The e-copter is equipped with an automated control system and is designed to fly along predefined routes. Vertical takeoff and landing allow it to use small sites and building rooftops, making it a promising solution for future air taxi networks and rapid urban delivery. Another flying vehicle of the future was introduced by French aviation inventor Frankie Zapata. His air scooter, a personal vertical takeoff and landing aircraft for one person. The air scooter is a compact hybrid electric vehicle that combines features of a large drone and a mini helicopter. Its flight system uses a hybrid powertrain electricity plus a small engine, providing up to 2 hours of flight time and a longer range than many fully electric counterparts. The cruising speed is estimated at approximately 80 to 100 kilometers per hour, with a maximum speed of around 100 kilometers per hour, making it suitable for short-distance leisure and transport tasks. One of its key advantages is ease of control with computer-assisted fly-by-wire support, helping maintain balance and direction while reducing pilot skill requirements. You are looking at a flying taxi of the future called the DTAE Toll 2, an electric vertical takeoff and landing aircraft developed by the French company DTAE Aircraft Manufacturer. The DTAE Toll 2 is being designed as a compact multi-motor aircraft for one pilot and one passenger. It is built as a multi-copter with 8 propellers, mounted at the ends of 4 support booms, powered by brushless electric motors. The airframe is made of composite materials to combine strength and lightweight. The cockpit is fully enclosed with a transparent panoramic canopy, providing excellent visibility for both pilot and passenger. And for easier access, it features gull-wing doors on the sides. The seats are arranged in tandem. One of the key features of this eVTOL is its energy efficiency and flight endurance. The aircraft can remain airborne for about 2 hours on a single battery charge, and its cruising altitude can reach approximately 4,000 meters. In China, the world's first 5-ton electric vertical takeoff and landing aircraft called Matrix was introduced, developed by the company Autoflight. It is currently the largest eVTOL in its class and has successfully demonstrated a full transition flight, vertical takeoff, transition to horizontal mode, and subsequent landing. The Matrix belongs to the 5 tons class. Its wingspan is about 20 meters, its length exceeds 17 meters, and its maximum takeoff weight is over 5 tons. The aircraft is developed in several configurations. The passenger version accommodates up to 10 people, while the cargo version can carry up to 1.5 ton of payload. Its design combines a fixed-wing aircraft configuration for efficient horizontal flight with distributed electric propulsion for vertical takeoff and landing, an approach that significantly increases range and energy efficiency compared to conventional multicopters. Write in the comments what you like the most after watching this video. Subscribe to the Corio Show channel so you don't miss the next episodes. Bye for now.